start with the digital electronics. Okay.
Digital electronics. Okay, ma'am.
So what do you mean by the digital electronics?
Ma'am,
I'm saying that what do you mean by the digital electronics?
normally, computer will understand the data in terms of zeros and ones. So according to that, we are going to design devices in such a way that it will convert what is analog signal into digital and then process it. So for that, we are going to use AND gates and logic gates to process all the data.
Okay. What's the difference between the analog and digital signals? Yeah.
Will you repeat the question again?
What do you mean by the difference between the analog and digital signals?
Voice is not audible.
Hello.
It
What
is
is the difference between the analog and digital signals?
what is digital electronics?
No. What is the difference between the analog and digital signals?
What is difference between analog and digital?
Yes.
One analog is continuous data, continuous signal, but in which there will be numbers from 0 to infinite. But in digital, there will be, it is also a continuous signal, but it is having only zeros and one as a data.
Digital signal is a continuous signal.
It is discrete, ma'am. Discrete and having data in terms of zeros and ones only.
It is discrete or continuous. Please say one.
No?
It is discrete or continuous. Which one?
Digital is discrete, ma'am.
Okay. So what's the difference between the discrete and digital signals? You have not answered yet.
No?
What's the difference between the discrete and digital signals?
What are different types of digital signals?
No, what's the difference between the discrete and digital signals?
Discrete and digital.
Yes, yes.
One discrete signals will contain not only zeros and ones, but also two. It will represent many more numbers. But digital only will represent zero and one in your signal.
So in discrete signal, uh, we have both the sides, both the axis as discrete or continuous.
Okay.
No, I'm questioning you.
In which axis they are discontinuous? You are asking me.
Yes, which axis it is discrete or
Uh,
continuous?
Digital is continuous in y-axis, ma'am. Discrete in x-axis.
Digital is continuous in y-axis, you're saying.
No?
Digital is continuous at y-axis, you're saying. I have a question that if the digital signal is continuous at y-axis, so can we have the bit 1.1 or 2.2? We have this type of bits.
No, ma'am.
So how it can be continuous?
Okay.
Yeah. So
It
do you
is
know the difference
discrete.
between the discrete and digital signals?
Discrete signals are, it can have values of 1.1 and 0.2, like that it will have, ma'am. But in digital signals, only zeros and one will be the values. available?
So I'm providing you the answer that the for discrete signals at y-axis it can be continuous, and at x-axis it is discrete. Okay, so remember, and you can
Dis digital signals, ma'am.
for discrete signals, and for digital it is discrete for both the axes.
Okay.
Yeah, for discrete signals it is continuous for the y-axis and discrete for the x-axis.
Digital signal, ma'am.
No, how it can be digital signal? I'm saying that discrete signal are continuous at the y-axis and um,
Discrete at
discrete
x-axis.
at x-axis. Yes.
Okay.
Mm. So next question is, what do you mean by the two's complement?
Two's complement is in two's complement we can represent a negative number in a positive way by placing MSC bit as 1. It represents a negative number. If MSB bit as 0, it represents a positive number.
So what's the
Uh,
two's complement? Why we take it?
Ma'am, actually in one's complement there is a disadvantage of representing 0, ma'am. So that problem will be overcome by using two's complement. One's
What problem?
complement
But
in one's complement we have a disadvantage of representing 0, ma'am. 0 we can't able to represent in one's complement, ma'am. Some representation of 0 in two's complement, ma'am.
okay. So do you know about the range of one's complement or two's complement number?
Yes, ma'am. It is minus 2 power n minus 1 to plus 2 power n minus 1 in one's complement, ma'am. And in two's complement, it is minus 2 power n to plus 2 power n minus 1.
And for unsigned integer, what is can be the range for two's complement for unsigned?
Unsigned integer from 0 to 2 power n minus 1, ma'am.
Yeah. So don't you think that for negative number we use the two's complement for signed numbers? Like generally we use two's complement for the negative number, right? To represent the negative number.
Ma'am.
Okay. So do you know about the Johnson counter?
Ma'am, in Johnson counter, there will be a last bit will complemented bit will be given as a MSC bit, ma'am.
Okay. So what do you mean by the finite state machine, FSMs?
Finite state machine, it is normally used to detect the sequence of the digits that we give, ma'am. So if the sequence of digits are detected, it will give output as 1. If not, it will give output as 0.
Okay, but what is the difference between the Moore and Mealy machine?
Uh, Normally, number of states it will represent, ma'am. While while representing a finite state machine diagram in More model, it will be n plus one, ma'am. N plus one states will be represented. In VLA model, n states will be represented.
Okay. Do you know the sequence detector?
Yes, ma'am. I will consider that.
So what it is?
Ma'am.
So what it is? What is the sequence
Sequence
detector?
sequence detector is it will detect what we are giving. If it is correct sequence as it is, if it matches with the sequence that is present in that, then it says like output is sequence detector, and if not, then it will give wrong sequences detector. It is
Okay.
same as FSM only.
Okay. Can you write the 2:1 mux Verilog code?
Yes, ma'am. Uh, shall I
Yeah.
share the screen, ma'am?
Yeah. Okay. Your choice that how you are comfortable. You can write it on a page and show me, or you can share the screen.
Okay, ma'am. I will share the screen. In Notepad, I will write.
Okay. Okay. That's fine. You submit.
Two is to one more.
Okay. For D flip flop. I want with asynchronous and synchronous reset.
Synchronous reset.
I want the two parts. First will be the asynchronous and second will be the synchronous reset. Okay.
Okay. And it is for asynchronous thesis problem.
Okay, you have written the two else condition.
Okay, ma'am.
This is for asynchronous or
Ma'am,
synchronous.
asynchronous.
Asynchronous, right? For the synchronous also.
For synchronous, it will come like this for synchronous. Ma'am.
So you have used the as I can see, you have used the always an initial together, and you have not written the end anywhere.
No,
So you have negate the else. Um, are you sure that the else statement, your else statement, can you like justify it? Explain me why you have written that at what logic.
Ma'am, T flip-flop is like when clock is high, it will toggle the previous output.
So so it the output is the negative of the in input, like what?
So, ma'am, if input is one, it if input is one, then output. If clock is one, then output will be come like. Ma'am, it depends on previous output, ma'am. I can say it through graph, ma'am. If previous output
But
is
no. Can you draw the truth table for the D flip flop?
if problem.
Truth table.
Okay. Okay, good luck.
I have asked you the truth table.
This is a good thing.
So, what is the definition of the truth table?
Whatever the inputs are there, that will be in P, and according to the inputs, we will write outputs. These characteristic table.
Yeah, that what I am trying to say you.
Okay.
Per code, I think Q is the output, right?
Okay.
But variables you have taken, what is T and Q in your truth table?
Uh, T is the input now.
Okay, so Q is the output, right?
Yes, ma'am.
So, but are you writing like TQ and 0110? What is this?
Yeah, Raman. I'm trying to write truth table, ma'am.
Okay, so it starts from 000110 and 11, right?
Yes, ma'am.
So,
Now, now I should write a ma'am.
okay, leave it. But I was trying to say you that when we, okay, so tell me that if you give the input to the D flip flop, what output you will get? The same as the input or the negative of the input?
Same as the input, ma'am.
So, in your code, you have written the negative of the input.
Ma'am, it is T flip-flop, ma'am.
So, I was trying to say that D flip flop, not the T flip flop.
Okay, ma'am. Then it will be that's it, ma'am.
Okay. Okay, fine. You can. The output of this question.
Output is 0, ma'am. Y will be 0.
Okay, fine. And for this one,
Clock is 1.
what?
Clock is 0, here A is 1 and B is 0. After the delay, when clock is 1, at passage of the clock, A and B will be assigned to X and Y, ma'am.
Okay, so what will be
So,
the final value of x and y?
final value is equals final value will be A is equals to 0 and B is equals to 0.
No, the display function is in x and y terms, right? So please tell me in the x and y terms.
So X will be 0 and Y will be 0 number.
How?
Here at zero, when after here clock period is 10 mm.
Do you know the difference between the dollar display and dollar strobe?
Yes, ma'am.
So what's the difference?
Ma'am, dollar display will display whatever the we want to display. Then, if dollar strobe is
No, no,
whenever the
whatever will be
input
displayed in the both, but at what time? I'm asking in reference to the time, like when the dollar display will display at what time and when the strobe will display.
dollar display will display this in 10 nanoseconds. Yes,
So you are saying that dollar display execute dollar display statement execute at the last of the statement at the last of the simulation.
this code it will execute at last minute.
What?
This code it will execute at last minute. Dollar display.
At what? At 10 nanosecond you are saying.
Yes, ma'am.
But dollar display will display at zero time at what time there is no given time, right? So it will display immediately. It
Yes,
don't
ma'am.
it will not wait. But in terms of dollar strobe, it will display after executing all the statements.
No, ma'am. Dollar strobe will execute whenever the uh, uh, time delay changes. Ma'am. Only once it will execute. Ma'am.
Okay, so dollar display will display immediately. I'm saying that.
Yes, ma'am. Dollar display will display immediately.
So why you are saying that at 10 nanosecond it will display?
Ma'am, in this code it will display after.
But
Okay,
why?
ma'am. Y is in this X will be 1, ma'am. Y will be 0, ma'am.
Okay, now it's correct. Have you done the system Verilog?
No, no, not again.
Okay, so how many devices can we connect on the I2C bus?
We can connect any number of masters and any number of slaves, ma'am.
Okay, so why the pull-up register are required in my I2C?
I don't
Yeah,
have idea of that question.
so what are the stop and start conditions?
Once I have to refresh that what I have. It is understood.
I have not taken your introduction, so can you give that right now?
Introduction, ma'am.
Yeah.
In SPI, it is a
No, your
small,
introduction.
it is
I have not taken that in the starting, so can you give it right now?
self-introduction.
Yes, yes.
Uh, Good afternoon, ma'am. My name is Sheikh Afrin. At present, I'm doing MTech second year in NIT Pondicherry in VLSI design. Previously, I done my BTech in Andhra Pradesh in a triple department. Uh, so according to my course, I have completed projects such as FIFO, RAM, and sequence detector. Uh, and if it comes to my co-curriculum activities, extracurriculum activities, then I'm class representative.
Have you done the UART?
No, no, not it.
Somehow you know about the baud rate. What is baud rate?
I
Oh,
started from I2C and SPM.
okay, okay. So what are the application of SPI? Why we use SPI protocol?
Ma'am, it is to communicate short distance. It is used for short distance communication.
Oh, how you are you have created that in what software you have created?
Ma'am.
In what software you have created the SPI protocol?
Normally, I didn't execute the code, ma'am, but it is done in fast.
You have not executed the code.
No, 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 I didn't
So
execute.
so you have just read about it.
I got to know about it, ma'am.
Okay, and same for I2C and FIFO.
No, 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 ma'am. Before I have executed. Only
Uh,
I2C and SPI or recently I have completed.
Okay, so today in the doubt session class at 9:30, you have to come and we will discuss about the FIFO you have done. Have you have it right now? The FIFO code you have executed.
I don't have that code now because I have executed in college computer.
Okay, so yeah, do you remember that what you have executed and how you have executed? You know all about it, right?
It's in FIFO there will be four states, ma'am. One is read, write, and full and empty, ma'am. And along with that reset.
No, okay. You know all about it, right? And that how we can execute it and how we run the FIFO code and how
Yes,
we
ma'am.
write it.
I know that.
Okay, okay. So today at 9:30, please come in the doubt class. We will discuss about it.
Okay, ma'am.
Okay. So what's the difference between the SPI and I2C protocol?
According to applications, they are different. But also in SPI, only single we will discuss about single master connected to multiple slaves. But
Okay.
in I2C, multiple masters will be connected to multiple slaves.
So both are full duplex.
Uh, SPI is used for short distance communication, and I2C will be used as a register.
No, I am talking about the full duplex or half duplex
I2C is full duplex.
and I2C.
I2C is full duplex.
Okay, so SPI.
SPI, I don't have duplex.
So how I2C is full duplex? Do you know about do you know the meaning of full duplex?
Because it is connected to multiple masters, in that way it is full duplex.
No, no. What do you mean by the full duplex? What is the full duplex transmission mean?
Means slave also will communicate through mass. Through
I think that I do see
both.
is half duplex.
I
No,
don't
in
have
terms
idea
of,
of duplex.
have you read about the DC and digital communication subject?
DC in digital communication.
In that topic, you have must read about the transmission, half duplex, full duplex transmission.
Ma'am, I am from Triple department.
Okay, 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 fine.
In BTech, I did from Triple, ma'am. At present, I am doing here MTech in VLSI design.
Okay, okay, fine. Do you know about the chip select? Okay, okay, that's all from my side. Okay. Do you have some questions for me?
What are the points that I have to improve for next mock interview?
Yeah, I think you must have the deep knowledge of everything. I think you have just learned the things right now because maybe you are from Triple E branch and this VLSI is new for you. So you are just learning things rather than reading it in detail and learning them. You are just learning, I think.
Yeah. So I have to learn in detail about every topic.
You have you must have the detailed explanation that how we think things are working, that how the how the protocols are working and their detailed explanation.
Okay.
In same goes for the every topic in digital and Verilog also. You were good at some point at the coding. You were saying the right output, but you must have the deep
Explanation
knowledge.
is little bit
Yeah, explanation. You must have the deep knowledge about it. Like I think you are not have that much knowledge right now. You must have the knowledge about how the like you have written the initial and always block together. Yeah, so you need a practice.
okay.
Okay, okay. So okay, thank you.
Thank you.
More questions? Any more questions you want to ask?
That's it, ma'am. If I have any doubts, then I will clarify
Yeah, you can contact me or we daily have the DAO session at 9:30, right? So you can ask at that time.
Okay.
Okay, thank you.